James Webb just saw Pluto for the first time. And this is horrifying. For nearly 100 years, we treated it as an afterthought, a frozen pebble at the edge of the solar system. So small and so far away that we couldn't even decide whether it deserved to be called a planet. In 2006, we took its title. It became the only world in the history of astronomy that was discovered, classified, then officially demoted by a vote. Then James Webb pointed its golden eye at it. And what came back through that mirror is something nobody was prepared for. This is the story of what the most powerful telescope ever built found out there in the dark, and why it should unsettle you more than almost anything else we've discovered this century. To make sense of why Webb's observations matter, you have to know what Pluto was supposed to be. Clyde Tombaugh discovered it in 1930 from an observatory in Flagstaff, Arizona. He was 24 years old with no college degree. He spent night after night comparing photographic plates, hunting for a single dot that moved against the background stars. When he finally found one, the world had its ninth planet, and a Kansas farm boy had carved his name into the sky. For most of the next 75 years, almost everything we knew about Pluto was a guess. It was a smudge of light, too small to resolve, too far away to reach. We knew it was cold. We knew it was tiny. We knew its orbit was a strange, tilted ellipse that swung it inside Neptune's orbit for 2 decades at a time before flinging it back out to over 4 billion miles from the sun. Beyond that, Pluto was a placeholder, a name on the wall chart at the back of a 5th grade science classroom. Then, in July of 2015, after 902 years of travel, the New Horizons spacecraft screamed past Pluto at over 30,000 mph and changed everything in about 10 minutes of close approach. What it photographed was not the dead world anyone expected. There was a heart on the surface, an enormous pale region shaped almost exactly like a valentine, stretching about 1,000 miles across, slightly off-center, pristine and bright against the surrounding terrain. Mountains rose nearly 11,000 feet into the thin sky, taller than any peak east of the Mississippi River, carved out of water ice frozen so hard it behaved like granite. Plains of nitrogen ice flowed slowly across the surface in cell-like patterns, churning and resurfacing themselves in a way that hinted at something warm beneath. A thin nitrogen atmosphere wrapped the whole world in dozens of layered hazes, blue against the black of space, stretching hundreds of miles above the surface. Pluto wasn't a frozen corpse, it looked alive. For years afterward, that single flyby was the only close-up data anyone had. New Horizons kept going deeper into the Kuiper Belt. While scientists picked through its photographs and spectra for clues, they modeled, they argued, and they wrote papers, but they couldn't go back. The probe was already 1 billion miles past Pluto and accelerating away. Anything they didn't catch on that single pass, they would never catch again. Webb is not a flyby. It doesn't take portraits. It takes fingerprints. Every wavelength of light a planet reflects or emits is a chemical signature, and Webb is built to read those signatures with a precision no telescope in history has ever had. It doesn't have to fly to Pluto. It just has to stare at the right pinprick of light from its position about 1 million miles from Earth and let the photons do the work. In late 2022, Webb started doing exactly that. What it found is harder to describe than what New Horizons showed us because Webb doesn't deliver a picture. It delivers a list of molecules, a temperature map, and a series of patterns that nobody was expecting. The first surprise was the haze. Pluto's atmosphere, thin as it is wrapped in layered hazes made of complex hydrocarbons. That much we already knew. What we did not know is what those hazes were doing. Back in 2017, a planetary scientist argued something that sounded almost absurd, that Pluto's haze was not warming the atmosphere the way haze does on Saturn's moon, Titan. It was cooling it. The haze particles, he proposed, were absorbing sunlight and then radiating that energy away in the mid-infrared, dumping heat into space faster than the atmosphere could replace it. An international team led by astronomer Tanguy Bertrand used Webb's mid-infrared instrument to measure exactly that. Pluto's haze is bleeding heat off the dwarf planet. The atmosphere is being actively chilled by the very particles suspended inside it. Nothing else in the solar system has an atmosphere like this. Pluto is cooling itself, and nobody knows how to fully model what comes next. The chemistry is the second piece. Sunlight, even the faint trickle of it that reaches the outer solar system, hits methane molecules in Pluto's upper atmosphere and breaks them apart. The fragments recombine into heavier compounds, ethane, acetylene, and ethylene, a whole zoo of hydrocarbons that grow heavier and heavier as they fall back toward the surface, eventually clumping into reddish-brown organic particles called tholins. New Horizons spotted some of these compounds during its flyby. Webb has now resolved them at a level of detail no instrument had ever managed before. Tholins are what give Pluto its color. They are also the same class of molecule that scientists believe rained out of Earth's early atmosphere, and may have contributed to the chemical soup from which life later emerged. On Pluto, they fall like a slow, silent 4 billion year snowfall, coating the surface in a layer of frozen organic chemistry. The sky on Pluto is dropping the raw ingredients of biology onto a world too cold for any of them to ever do anything. The chemistry of life, frozen mid-step. The numbers behind that picture are difficult to grasp. Sunlight at Pluto is about 1,000 times dimmer than sunlight on Earth. Noon on Pluto is darker than the worst overcast evening you have ever stood in. The temperature on the surface hovers between about 387 degrees Celsius and 369 degrees Celsius, colder than anything ever measured naturally on this planet by more than 250 degrees. The coldest temperature ever recorded at a research station in Antarctica was around 128 degrees Celsius. Pluto belongs to a different category of cold entirely. At those temperatures, the air you are breathing right now would freeze. Nitrogen, the gas that makes up 78% of Earth's atmosphere, becomes a snowflake on Pluto. Methane, the main component of natural gas, becomes a glacier. Carbon monoxide, a deadly gas at room temperature here, falls as crystals there. The very chemistry of our air is the chemistry of Pluto's surface, frozen solid. The third finding is the one that should make your skin crawl. Pluto is leaking, slowly, constantly, every second of every day. Methane and other molecules drift up from its faint atmosphere, escape its weak gravity, and disappear into space. That part scientists already suspected. What they did not know is what was happening to the lost material. It was not lost. Something was catching it. Pluto's biggest companion is its moon, Charon, a battered ice world about 750 miles across, locked in a tight gravitational dance with the dwarf planet. Charon has no atmosphere of its own. Its surface is bare water ice, ancient and cratered. Yet its north and south poles are stained with a strange reddish-brown deposit, darker than anything else on its face. For decades, planetary scientists had a hunch about where that color came from. They couldn't prove it. Webb proved it. In a series of papers published in 2024 and 2025, the same international team that confirmed the haze cooling effect also showed that Charon's red poles are made of Pluto's stolen breath. Methane molecules escaping Pluto's atmosphere drift across the roughly 12,000 miles separating the two worlds, get pulled in by Charon's gravity, freeze onto its poles, and then get cracked apart by sunlight and cosmic rays into heavier organic compounds. The same kind of chemistry that paints Pluto reddish-brown is being performed on Charon's face, using ingredients siphoned straight out of Pluto's air. Nothing else in the solar system does this. No other world is bleeding its atmosphere onto a moon and dyeing that moon with the leftovers. Pluto and Charon are locked in a quiet, slow vampiric exchange that has been happening for billions of years, and we only just figured it out. Webb saw something else on Charon. In October of 2024, a team led by Sylvia Protopapa at the Southwest Research Institute confirmed the presence of carbon dioxide and hydrogen peroxide on Charon's surface. Carbon dioxide is the gas you exhale. Hydrogen peroxide is the bleach you'd pour on a cut. Both are sitting frozen on a moon billions of miles from Earth, manufactured by radiation breaking apart the water ice on its surface and rearranging the pieces. That is the world Webb has been watching. A bleeding planet feeding a poisoned moon hidden behind hazes that are slowly cooling the planet to death. If you could somehow stand on Pluto's surface, this is what you would experience. The sun would still be visible, but only as a piercing point of light, brighter than any star in our sky, yet smaller than a pinhead held at arm's length. There would be no warmth from it, no glare. You could look directly at it without flinching. The sky around it would settle into a perpetual gray-blue gloom, thick with frozen haze. Neither day nor night, just a permanent twilight that never lifts. The ground beneath your feet would not feel like Earth. While water ice at 380 Bidegger is not slippery and crystalline, it is rock. It rings like steel when struck. You could swing a sledgehammer at it and bounce off without leaving a mark. If you tried to breathe, the air would not fill your lungs. The atmosphere is about 100,000 times thinner than Earth's. There is essentially nothing to breathe. But that is the second thing that would kill you, not the first. The first thing would be the temperature. Exposed skin would freeze faster than it could register pain. Your tears would crystallize before they fell. Your blood would slow, then thicken, then stop. And then it would snow on you. Not water snow, nitrogen snow. The same nitrogen that fills your lungs every time you take a breath, drifting down from the sky and settling on your frozen face as fine white powder. Overhead, Charon would hang in the sky and never move. The two bodies are so closely matched in size that they don't orbit each other the way Earth and the Moon do. They orbit a point in empty space between them, locked in a slow waltz that takes a little over 6 Earth days to complete. From the surface of Pluto, Charon would always be in the same spot, the same face turned toward you, looming overhead like a frozen gray eye that never blinks. And from Charon, Pluto would do the same. Two worlds staring at each other across 12,000 miles, exchanging atoms in perfect silence. Pluto's seasons make all of this worse. Its 248-year orbit is so stretched out that for decades at a time, the dwarf planet pulls much further from the sun than at other periods. As that distance grows, the temperature drops just enough that nitrogen, Above the surface, condenses and snows onto the ground. The atmosphere freezes out. It falls. It settles as frost on the cold side of the world and waits, sometimes for a century, before the next pass closer to the sun sublimates it back into a gas. This is a planet that breathes on a 248-year cycle. And right now, it is exhaling. The surface of Pluto has more secrets than the atmosphere does. East of the heart, in a region called Tartarus Dorsa, New Horizons photographed something nobody had ever seen anywhere in the solar system. A field of ice spikes, rows of jagged blades made of frozen methane, the tallest, reaching as high as 1,500 feet off the ground, lined up in nearly parallel ridges with gaps of 2 to 3 miles between them. On Earth, similar formations, called penitentes, form in high-altitude deserts and rarely grow taller than a person. The blades on Pluto are dozens of times larger. A 2025 study of New Horizons data suggests these structures may stretch across roughly 60% of Pluto's equator, ringing the entire dwarf planet in a belt of frozen knives. West of the heart, the surface looks burned. A dark, sprawling region named Cthulhu drapes the equator like a stain, reddish-black and ancient, larger than the state of Alaska. The darkness is built from accumulated tholins. The organic chemistry, the haze, has been raining down for 4 billion years, piled thickest, where the lighter methane and nitrogen ices can't keep covering the ground. Cthulhu is the part of Pluto that has soaked up the longest exposure to that slow chemical poisoning, the oldest face of the dwarf planet, wearing its history as a shroud. South of Sputnik Planitia, 2 enormous isolated peaks rise out of the surrounding terrain. Reitmanns's stands about 13,000 feet tall and roughly 100 miles wide at its base. Picardmons, just to the southeast, rises higher still, possibly close to 20,000 feet, with a footprint that rivals Mauna Loa, the largest active volcano on Earth. Both peaks have a deep central depression at the summit, ringed with concentric fractures and lumpy, hummocky flanks that look exactly like the cooled lava flows of terrestrial volcanoes. They might be cryovolcanoes, mountains that once erupted, not magma, but a slurry of water, ammonia, and methane from somewhere deep below Pluto's crust. The interpretation is still debated. Some researchers think the whole region was reshaped by many vents over long periods, rather than by a few colossal eruptions. Either way, the implication is the same. Something pushed liquid material up through the ice in the recent geological past. Pluto, the world we thought was dead, has a heat source. It has been warm enough, at some level beneath its frozen shell, to melt ice and force it to the surface. We don't know when those mountains last erupted. We don't know if they still do. In the silence around all of this, Pluto's smaller moons spin: Nix, Hydra, Kerberos, and Styx. 4 icy bodies named after figures from the underworld, none larger than about 35 miles across, all locked in chaotic, unpredictable rotations, because the shifting gravity between Pluto and Charon never lets them settle. They tumble end over end, never showing the same face twice in a row. No other system of moons we have ever seen behaves this way. The implications go further than the chemistry. For most of the 20th century, we thought of the outer solar system as a wasteland. Anything past Jupiter was either gas, ice, or rock, too cold and too far to be interesting. Pluto was supposed to be the postscript at the end of the textbook. Webb has destroyed that idea. The chemistry Pluto is performing in its upper atmosphere is the chemistry of an active world. The organic compounds it is generating are not leftovers of an early formation event. They are being made right now, in real time, by sunlight and gas reacting in ways that prebiotic Earth would have recognized. Pluto is running a chemistry experiment at the edge of the solar system, and it has been running it for over 4 billion years without stopping. And underneath all that ice, Pluto may be hiding an ocean. This is one of the most controversial claims in modern planetary science, and the evidence keeps building. The pattern of cracks and ridges on the surface is consistent with an ocean of liquid water trapped maybe 100 miles down, kept warm by the slow decay of radioactive elements in Pluto's rocky core. The shape of Sputnik Planitia, the western lobe of the heart, points to a positive gravity anomaly, something dense sitting below it. Liquid water, denser than the ice above, fits the math. If that ocean exists, it has likely been there for billions of years. It is dark, it is salty, it is under enormous pressure, and it is one of the most promising places in the solar system to look for the conditions under which life could exist independently of a star. A pocket of liquid water kept warm by Pluto's own dying internal heat, fed by hydrocarbons drifting down from the surface through cracks in the ice, sealed off from the universe by a shell of frozen rock harder than anything on Earth. That is what may be sitting at the bottom of the world we used to think was nothing. We can't get to it, not yet. Maybe not for a very long time. New Horizons gave us a single flyby. No Pluto orbiter is on the books, no lander, no funded mission. The reason is simple. The journey takes a decade, the engineering is monstrous, and the budget for outer solar system science has been shrinking for years. Webb is currently the best tool we have for reading Pluto in fine detail. Every few months, when Pluto comes back into the part of the sky Webb can observe without baking its instruments, the telescope swings around and stares at it again. Each pass refines the chemistry, each pass tightens the model, each pass adds another data point to the question of what is actually happening out there. And every pass so far has made Pluto stranger than it was the day before. One more thing about Pluto, and it's the part that gets me every time I think about it. Pluto is not alone. The Kuiper Belt, the vast donut-shaped ring of icy debris beyond Neptune, contains hundreds of thousands of objects larger than 60 miles across, and an estimated trillion comets. Most of them are tiny. A handful are nearly Pluto-sized, like Eris and Makemake. The rest are smaller, scattered across a volume of space hundreds of times larger than the asteroid belt. Beyond the Kuiper Belt, the Oort cloud is thought to contain another trillion comet-sized bodies, stretching out a quarter of the way to the nearest star. If Pluto is doing this, others probably are too. We are looking at a single well-studied example from a population we know exists, but can barely see. Webb can squint at the bright ones, the larger objects close enough to reflect a useful amount of sunlight back at us. The rest are nearly invisible, trillions of frozen worlds, each one potentially performing some version of the slow, silent organic chemistry we see on Pluto. Each one potentially hiding an ocean, each one drifting through the dark with no one watching. The outer solar system is not empty. It is a graveyard so densely populated that we cannot count the bodies. And every one of them is doing something. When New Horizons flew past Pluto in 2015, the mission's principal investigator, Alan Stern, said the photographs would haunt him for the rest of his life. He was talking about the beauty, he was talking about the unexpected geology, he was talking about the fact that a world we thought was dead turned out to be alive in ways no one could have predicted. Webb has taken that haunting and made it permanent. The data keeps coming, and every batch makes the picture stranger. Pluto is not a planet. It is not even quite a dwarf planet in the cold, inert sense that phrase was originally meant to convey. It is something else. A frozen chemistry lab. A bleeding world feeding a poisoned moon. A possible water world beneath a stone-cold shell. A herald of the trillion other worlds we cannot reach. The universe out there is colder than anything in your experience, and darker than anything you have ever seen. It is also busier than we thought. Quietly, slowly, on timescales that dwarf human history, doing things we are only beginning to understand. Pluto isn't a postscript. It is a warning. There is so much more out there, doing so much more than we ever imagined. And we have barely started to look. And that's it for this video. Thanks for watching, and I'll see you in the next one.